Hello, and welcome to Concepts Covered, where I cover various college concepts. My name's Erin, and today we'll be looking at a physics concept called static equilibrium. We have a problem here that reads, a wrecking ball weighing 2,500 newtons hangs from a cable. Before it starts to swing, it's pulled back to a 20-degree angle by a second horizontal cable. What is the tension in the horizontal cable? The first thing I like to do when approaching physics problems is to pick out the bits of information that I think will be useful to solve the problem and centralize them. Here, we have the weight of the wrecking ball, which is the same as the mass times gravity, which has been given as 2,500 newtons. Secondly, they have given us an angle of 20 degrees. Next, I define what we're looking for. In this case, it's the tension of the horizontal cable. The next step should be creating a diagram to give this abstract concept some visualization. I added elements of a free body diagram to help with creating our equations. I broke the y and x elements up in order to find the sum of each force. Using some trigonometry, we can use the location of the angle to divide the x and y elements. The y component is the adjacent side, which is cosine. The element in the x direction is the opposite, which is sine. Looking only in the y direction, we can label the tension, which is going upwards in the positive y direction at an angle. This is written as T2 cosine of theta. The force of the weight is pointing in the negative direction, so we can label that as negative. Similarly, looking in the x direction, T2 is still positive and at an angle, and it is written as T2 sine of theta. The horizontal tension is pointing in the negative x direction, so that is labeled with a negative sign. From this data we collected from the diagram, we can start to create equations. Let's start in the y direction. The sum of the forces in the y direction equal T2 cosine of theta minus the weight of the wrecking ball equals 0. Remember that we are setting these equations to 0 because when you think of the formula for force, it's force equals mass times acceleration. Pretty iconic formula, but in this instance, the wrecking ball isn't moving and is in static equilibrium, meaning there is no acceleration, which means that this side of the equation is 0. Now let's isolate T2. Move the weight to the other side of the equation and divide both sides by cosine of theta. This equation right here gives us the tension of the vertical cable, which is not the right cable, but let's keep this equation on the side because it should come in handy later down the line. Moving on to the sum of the forces in the x direction, we can write T2 sine of theta minus T1 equals 0. Now we can isolate T1, which is our desired tension. In this equation that we created, we need the value of tension 2 in order to find T1. And luckily, we have the equation for that. Plug in the equation for T2 in place of the variable, and voila! That'll take us right to the answer we're looking for. I hope you found this helpful, and thank you for studying with me.